All right, and then we're on the last one. Thank you again, Valente, whoever you are. Okay, so nice little directions I think you've seen a billion times. All right, so here's letter A. Well, let's do the rubric first. I think I have them all with the answers there just so you can score yourself. Yoink, this is kind of a lengthier one. So, all right, so just take a look at those answers. I highlighted them. I think there was a mistake. Sorry, Valente, but I think I caught something that you did wrong here. So we'll talk about that in B1, where the answer, I believe, is actually zero. Confirmed with another teacher in our department, one of my comrades, which is just a general term, doesn't denote communism or anything like that. I'd never say anything derogatory with other teachers. So here we go. Um, I don't know what to tell you. There's really nothing to do on this first one. You just take that 2 and make it squared on the x. You see that 3 being thrown on the x plus 2, and that'd be cubed now. And then wherever there's a minus sign on logarithms, that goes on the bottom of a condensed logarithm. And then I just put a highlighted that it's plus ln of x plus 5, so that means x plus 5 goes up at the top of that condensed logarithm. So that's the answer for the first part. Second part is a little bit of a doozy. I don't know how many we had where we had to get a common denominator in our regular class. We didn't go too in depth with our identities, but that's what this implies. You do something, not nothing. So usually you turn everything into terms of sine and cosine. Then I look at this and, oh my gosh, if you cross cancel over a plus sign, you should be kicked out of my class immediately. That is not what happens in simplifying fractions from grade school. So what you got to do is get a common denominator. So multiply top and bottom green sine x there. Okay, get my pointer going here. And then multiply top and bottom by cosine here. Oh, because then I could see the future and it looks bright. Sine squared plus cosine squared, I know equals to 1. And the directions say put this in terms of secant and cosecant. And now I could see what's going on here. 1 over sine is cosecant times 1 over cosine, which is secant. All right, and then that's the final expression simplified. Next ones, so that's we can see those directions for A1, A2. Anyone ever have A1 steak sauce, by the way? All right, so functions j and k are given by blah, and then I was just lazy. What j of x equals -8? That just means we replace j of x with -8 and you solve. Let's do that one first. First thing you would do is add 12. So I'd add 12. 12 plus -8 class is 4. And then you divide by 4. I think this is where Valente went a little off on the answers here. Okay, and you got to get used to this. Is kind of newer for the regular class because we didn't really present these maybe in this way. We talked about it maybe graphically. Look at the graph of cosine of x over 2 and then see where 1 intersects, the graph. But what you can do is inverse cosine and just think what angles have cosine value of 1, and it is 0. And it's only 0. It's not pi. At pi, the cosine value is -1. And then what you do then is solve for x, which just requires you multiply by 2. So in a way, whatever you do to one side, say it. And then this was in the Get Triggy With It video, those that have ever had me. My pens won't activate. I got to slam it on the ground. That's the only way to make technology work. Just remember that. All right. And then cosine inverse of both sides. So then that frees this, and then all I have to do is answer this, but don't worry about restrictions. You got to worry about all the quadrants from 0 to 2 pi. And then it's 0. And then when I multiply both sides by 2, 2 times 0 is still 0. So that's why I believe the answer is 0 there. Now for the log equation, I replace k of x with 3. And then this is a... Anyone in my class that's ever had a logarithm knows that's the sound for changing a log to an exponent. Base, exponent, answer. And I told you you'd fail miserably on that test if you didn't know how to change a logarithm to an exponent and vice versa back in that day. And some people did. 3 cubed is 27. Then you subtract 2, and then you square root both sides. And then interestingly, plus minus does work because you can square a negative, get a positive, and then you are logging a positive. So that's not an extraneous solution. Then this one was a little bit easier than ones in the past. Ones in the past said m of x equals the inverse cosine of, like, well, in this case, it's the inverse cosine of, I don't want to embarrass myself, 1/2. And then you had to evaluate that was 1/3 and then put that in that place, but whatever. All right, and then here's the work for this one. And then I went ahead and did this. So I replace m of x with 1 or pi over 3. And then now I multiply, don't divide by 2/5. Students are so bad with fractions. Multiply both sides by 5/2, the reciprocal. And then here we go again. Whatever I do to one side, I do to the other. I don't know what this fist is. What the heck is going on? What? Oh my gosh. Technology is just going to be the end of me. I'm going to take my fist and punch the screen if this doesn't stop. What is... I'm leaving this in again. My life. I have no idea. I can't access a pen. Power to the people. What is this thing? Why is this? Okay, that was fun. That was fun. Okay, all right. So I won't take my fist to this. That's violence. We shouldn't teach the children. Okay, so whatever I do to one side, as I was saying, we do to the other. So you cosine that inverse cosine for it to disappear. That means you have to cosine the other side as well. And by the way, 5 pi over 6, that's easy. All right. Cosine of 5 pi over 6 in quadrant 2 is negative root 3 over 2. I already have some canceling going on here. Then don't divide by 4 root 3. Multiply by 1 over 4 root 3. So you can see the actions of how this works in a fractional sense. And then the root 3's cancel real nicely. And then that's negative 1 over 8. So very nice solve. All right. And there you go. There's all 4 FRQs. We've done quite a few FRQs, and they all really end up being quite similar. So let's really hope we're pretty spot on, and that's how the AP exam looks. Hey, good luck, everyone. We truly do care and want you to get a 5 or a 4. At least maybe a 3, though, as well. Go get them.